So we'll give everybody a few minutes to get in, settled, and we'll be continuing with our discussion on functions. All right, so we've been going over functions, how to deal with different types of transformations of functions. We talked about shifts and slides, we talked about reflections, and we also talked about non-rigid transformations, so stretches and squishes. So we're talking about how to manipulate these parent functions into different new versions of that same parent function. So you can make a linear function into a different linear function, but you can't make a function into a different family. Well, we're going to start talking about how to combine different functions. So that's what we're going to get into today. Combinations of functions. So, like with any other mathematical object, what is the simplest way of combining two functions? What does it mean to combine two things?
Is it like to add or subtract them together?
Yeah. So we have sum and difference of two functions. Very good. So this is kind of a introduction to a shorthand that will come up time to time. Mathematicians are, we'll say, lazy or efficient, depending on how you like to phrase it. So we like to add or subtract whole functions without having to necessarily recopy down all of the functions. So if you take two functions, f of x, and add it to a different function, g of x, remember, when written like this is not f times x. This is f is a function of x, meaning f is a bunch of stuff hidden in the background that depends on x. So you can have like f of x equals x squared minus 3x plus 2. F of x just means you take whatever you put in this little spot called the argument, and you plug it in for x in that function. We don't always want to write out the function because sometimes the function can get big, and we don't necessarily want to keep rewriting. So shorthand for it, for a sum of two functions, f of x plus g of x, is f plus g of x. So when you see this, all you do is you write the function f plus the function g. Similarly with a difference, so all this is shorthand notation for writing these. So let's do an example real quick. Nothing crazy or spectacular going on. Let's say that f of x equals 2x plus 1, and g of x equals x squared plus x minus 1. So f plus g of x equals 2x plus 1, because that's f of x, plus x squared plus x minus 1. So all we've done is plug them in, and then we simplify things. So x squared is by itself, so it doesn't combine with anything. We have a 2x and an x here. And we have a plus 1 and a negative 1, which cancels out to 0. Then what I want to do is evaluate that so we get some practice remembering what it actually means. F plus g evaluated at 3. All we do is we take this f plus g and substitute a 3 in for the x. equals 18. So, like I said, nothing crazy, nothing wild. This is really just a shorthand for something that we've already done a bunch already. But it's very helpful shorthand. Okay. Well, what about f minus g of x? What does that equal?
X squared minus X.
So write out functions. So there's nothing with the x squared, so it's negative x squared. 2x minus 1x becomes plus x, and then plus 1 minus negative 1 plus 2. So evaluate that at, let's say, 4. What do you get?
Nine.
You get 9. So let's see. Negative 4 squared is negative 16. Plus 4 is negative 12. Plus 2 is negative 10. So this is the shorthand for just adding and subtracting functions. Don't overthink it. We're just doing stuff that we've already done a bunch of times. It's nothing too intricate. But there's other kinds of combinations we can do. So when we take a step up from addition and subtraction, what do we get?
Multiplication.
Multiplication and division. So we call those products and quotients. So product, the shorthand is FG of X. And the quotients F divided by G of X. All right, so let's say we have f of x equals 2x plus 2. G of x equals, I don't know, x squared minus 1. What is FG of x? How do we start that one? So it's just f of x times g of x. So we FOIL it first. Gives us 2x cubed. Outer minus 2x inner plus 2x squared last minus 2. So we can reorder that. 2x cubed plus 2x squared minus 2x minus 2. Okay, what about what does that one give us? All right. So simple, straightforward. These are all our basic combinations of functions. The last one that usually gives people trouble is called a composition of two functions. So let's look at that one. Save most of our time for that. All right. All right. So what is a composition? What does it mean to compose something? What does a composer do?
You mean in terms of music?
In terms of anything. You could talk about it in terms of music. You could talk about it in terms of
They're more like the director, I guess. They direct everything.
no, that's the director. Sometimes they're the same person. If you took a composition class, what kind of class is that?
Write, like create something.
Yeah, yeah. Literally means to write it. So this is the idea, is you're going to compose one function using the other one. So to write this out, this means a function f whose argument is another function. So it's kind of like a function within a function, or Inception, if that movie isn't too old for anybody to know about. But it's the same idea, and it comes from this idea to write. You're literally writing one function with the other function. So using these two, what does f o g of x equal? So when you have a function, what does f of x equal? Well, it equals 2x plus 2. But here, it's not f of x, it's f of g of x. So everywhere you saw an x in the function f, you put g of x. So we have 2 g of x plus 2. What does g of x equal? So everywhere you have a g of x, you put x squared minus 1. So 2 minus 1 plus 2. Simplify everything out. 2x squared minus 2 plus 2. 2x squared. So let's try and go the other way. Let's do g of f. Well, what about this one?
So I'm guessing since it works the same way, wouldn't it be 2x plus 2 squared minus 1?
Yeah, so first thing you do is you write g, but with f in its place. So f of x squared minus 1. And then if you continue further and you plug in what f is, you get two x plus 2 squared minus 1. This gives us 4 x squared plus 8x plus 4 minus 1. Yeah, so it works the same way. You just write one function in terms of the other one. And this is, like I said, this is the one that usually gives people trouble. So if it's not immediately obvious, that's kind of all right. But it is important because this is the only thing that's like really new about this section. The rest of it is just a how we write things is new. So this is a composition of two functions. So let's see what else this means. Where's my notes? Okay. So functions within functions. Nothing crazy, but definitely still new. So let's play with these for a second. In every other operation we've talked about, there is some sort of opposite of that thing. Addition, subtraction, multiplication, division, exponentiation, or squaring, cubing, that kind of thing, and square rooting or rooting, where if you do one of those things and then the other one, you get back to where you started, right? So all of that is directly tied to this combination of functions thing. So what did we say the opposite of of adding, let's say, 5 is? So let's say f of x takes x and gives you x plus 5. What is the opposite of adding 5?
Subtracting it.
Subtracting 5. Yeah. So if we set up our equation to be g x so this is our equation. What is f of g of x? And then also, what is g f of x?
Aren't both of them just x since both 5s cancel out each other?
You are exactly right. So let's just do it. F of x is g of x plus 5, x minus 5 plus 5. And then this is f of x minus 5. So yeah, very right. So these two functions, f of x equals x plus 5 and x minus 5, are linked together because when you do this operation, you get back whatever you started with. So it doesn't matter if it was x, you could have put 3 in there, it doesn't matter. But if two functions have this quality, then when you do f of g, you always get back the thing that is over here. Or g of f, you always get back the thing over here. And they both have to be true. You can't just do one of them and the other one to have this property. So let's look at next up. What about x times 5 and x divided by 5? Well, f of g of x, just because g of x times 5 equals x over 5 times 5 equals x, or f of x divided by 5 equals x times 5 over 5 equals x. So any pair of functions that you put in here that has this property, that when you apply it, this operation, both ways, they cancel out. F of x is the inverse of g of x. And the way we write that mathematically is f to the negative 1 so the inverse of f is g. This also implies that the inverse of g is f, but we don't write both of them because if one is true, the other one is. So this is a very important fact. Something that we use a lot when it comes to higher order math. So let's go from the other side. Let's not check to see if two things are inverses of each other. Let's find the inverse of two functions. So f of x is 3x minus 2. Let's find the inverse of this function. So when you invert something, you're basically just turning it around. So all of these functions, they're a process. You take something, you stick it in, and then you get something out at the end. Well, the inverse of that function should work the opposite way. You take whatever you start with at the end, and you get back whatever the other one started with. So we're about to run out of time. So we will continue on with this stuff on Monday, how we are going to find the inverse of functions. So, yeah. Well, if you guys have any questions, come see me in the office hours. Otherwise, yeah, have a nice, safe weekend. I'll see you guys on Monday.